Bismillahirrahmanirrahim. In today's lab, we will learn how to solve a circuit through K-map and MATLAB and how we can simplify our truth table Boolean expression into a simple K-map equation and then make a circuit with Proteus through that equation. So first of all, we have to make a truth table of our circuit. Here you see on the screen, I have made a truth table of our screen. There 4 inputs W, X, Y, Z and single output F. I have made that table when all the inputs are 0, 0, then our output will be 1. And when the inputs are 0, 0, 0, 1, then the output is 0. And when input is 0, 0, 1, 0, then the output is 1. And similarly so on for the other inputs. Now after this truth table, we have to make the equation from this truth table for our circuit. Now I have made this equation by using min terms. In min terms, we can represent the 0 value as a complement form and 1 as a non-complement. So here you see when our outputs are 1, 1, 1, I have written these numbers. F equals to summation of m, small m represent the min terms, and when output is 1, these are 0, 2, 3, 5, 6, 8 and so on. Now I have to write the equation in min terms. I have write the equation F equals to W bar, X bar, Y bar, Z bar product. It is the product of sum of product terms, SOP form. So first we have to take a product of these terms all, and then we have to take sum of all these terms. So it is sum of product terms. So first is W bar, X bar, Y bar, Z bar plus W bar, X bar, Y, Z bar and similarly so on. Now after this we have to make a K-map to simplify this equation and to simplify our circuit. Here you see on the screen I have made a K-map of our circuit. On the rows I have taken the WX and in the column wise I have taken the input YZ. These represents the inputs bit when the W is 0, X is 0, when the W is 0 but X is 1, and similarly 1, 1 and 1, 0, and this represents the inputs YZ 0, 0, 0, 1, 1, 1 and 1, 0. Then after this I have write our outputs. These are all our outputs. When the all are 0, then the output is 1. When the 0, 0, 0, 1, then the output is 0, and similarly all these. Then after this I have to make the pairs of 1. Here you see I have made these corner ones 4 pair. Okay, this is the ones in which 4 ones are paired in one pair, and then these 2 ones are pair, and then these 2s are one pair, and then these 2 ones are pair. Then I have to write the equation for this K-map. Here you see for the corner ones our Z remains the same and our X remains the same. So it is the simple equation for the corner ones, which is X bar and Z bar, because Z is also 0 and X is also 0, and in min terms we represent the 0 as a complement form. So that's why here I write the X bar and Z bar. Then we see these ones. For this one our Z remains the same, which is 1, and similarly WX. So this represents these ones, which is W, X and Z, and all are 1. After this we have to make a equation for these pair 1, 1. For this WX and here x remains the same for both of these, and similarly yz. So equation is x, y bar and z, and our last pair is this one. So for this one w remains the same, 0 and yz. So this equation represents this pair, w bar yz. Now I have completed all our theoretical part of simplification of a circuit. I have made the truth table, then I have derived the Boolean expression from that truth table. After that I have made a K-map and then derived the simplified equation from the K-map. Now our next step is to make a circuit on Proteus from these truth table equation and K-map equation and simulate it, and to verify that both equations give the same result. Now I have made the circuits of equations derived from the truth table and K-map on the Proteus. On the left side you see that this circuit which I have made from the equation derived from the truth table. Here I have used the 9 4 input AND gates because I have 9 values here as a product, so I use the AND gates for them, and then I have to add all these product terms, so I have used these OR gates, and finally our result is displayed on this LED. These AND gate represent the terms W bar, X bar, Y bar, Z bar, and then this AND gate represents the term W bar, X bar, Y, Z bar, and similarly so on. So I have made the circuit from the truth table equation. Then on the right side you see this circuit which I make from the K-map simplified equation, in which we have 4 product terms, so that's why I use 4 AND gates, and then I have to make sum of all these terms, so I have used this OR gate, and finally our result is displayed on the screen. So you clearly see that our K-map has really simplified our circuit. On the left side this circuit gave the same result, and similarly on the right side this circuit also gives the same result for the same input. So in this way K-map simplified our circuit a lot. Now when I run the circuit, here you see when our inputs are 1 0 1 0, and similarly here on the K-map our inputs are 1 0 1 0. Both circuits show high output because both circuits are equivalent to each other. The K-map is just the simplified form of this circuit, truth table circuit. Now when I change the inputs, I give the inputs 0 0 1 0, and this circuit shows the high output, and similarly when I give that input on the K-map circuit 0 0 1 0, this circuit also shows the high output because both circuits are same as a result. Now when I give the inputs 0 1 1 1, this circuit shows the low output because now LED is off. Now when I give that input on this K-map circuit 1 0 1 1 1, the K-map circuit also shows the low output. So you can see that K-map really simplified our circuit with no change in the result. So in this way we can simplify our circuit a lot by using the K-map technique and main terms. After the Proteus, I have to make that circuit on HDL Verilog. Here you see, first I have made a circuit from the equation derived from the truth table by the logic statement technique. Here I declare the module whose name is truth table and inputs and all outputs. After that I have declared the inputs. I have 4 inputs W, X, Y and Z. and then I have declared the output. I have a single output f. Then I have the assign statement in which our output f is equals to this. I have write this from by the logic statement type. First we have this bracket in which I have the not of w and with the not of x and with the not of y and with the not of z. So I have read this equation from the equation derived from the truth table. Means this equation I have write in the Verilog HDL assign statement by using this equation. So we have the 9 product terms, and after that we have to make sum of all that terms. So here you see we have these 9 terms which perform the AND operation, and then we have the OR operation between all these terms. So as a result, first we make the product of all these terms, and then we make sum of all these terms, and then our AND module. Now I have successfully simulate this program. Now I will make the university program to make our outputs and inputs relation. Here I not find a list, I have to make all the inputs and outputs, so this appears. Now I will give the time period to our inputs. I will simulate this. Simulation starts. Our simulation is complete and you can see the output waveforms. When our inputs are 0, 0, 0, all 0, then our output is 1. And when our inputs are 1, 0, 0, 0, then our output is 1. And when our inputs are 0, 1, 0, 0, then our output is 1, and similarly so on. So you can verify this waveform from the truth table very easily and can check our circuit. Now after that I have to make the code for the Verilog HDL for the K-map equation for this equation, and to verify that both code give the same result from the truth table and from the K-map. Now I have made this HDL Verilog code for the K-map equation. You can see that our this assignment statement is very simplified from the previous truth table equation. Now it is very easy from the K-map technique to write our code. Now we have only 4 AND gates and 1 OR gate. These represents in brackets, these represent the AND terms, and then this represents the OR operation between all these terms. Here I have first not of x and with the not of z, or with the not of y and not of z, and after that our output will appear. Now I have successfully compiled that program and I have made the output waveforms. You see on the screen that when all our inputs are 0, 0, 0, then our output is 1. And when the inputs are 1, 0, 0, 0, then our output is also 1. And when inputs are 0, 1, 0, 0, our output is 0. So you can verify that our results from the truth table Verilog code and the K-map code are both same. So we can verify that our results are same by both techniques. So in this lab we learned that how we can simplify our circuit and equations by using the K-map technique. So first of all, we have to make the truth table of our circuit, then we have to make the equation from the truth table, and after that we have to make the K-map, and then pairing of ones in the K-map, and then the equation by using these pairs, and finally our circuit is simplified. So that's enough for today's lab. Thank you.